we've been looking at a number of examples that all have to do with strings. Now, a lot of these examples have felt a little bit arbitrary, and that's because we've just been practicing how can we use these 4 different methods in interesting ways. Today, what we're going to do is we're going to make something that's a little more involved, and that something that's a little more involved is going to be the game of Hangman. So, to start, let's go ahead and actually play a game of Hangman, just so we get down the rules that we're going to be working with and start thinking about what this is going to look like when we start to make it. Now, in a game of Hangman, usually we have something that looks kind of like this, and ignore the fact that I'm using Autodraw. It's suggesting all these better versions of my drawings, because clearly that's not what I want. Usually I have some area over here where I'm writing down the letters that have been guessed, and I have some sort of hint down here. So let's just do 1, 2, 3, 4, 5 for that. It's actually really funny to see what the computer thinks I'm trying to draw. Hilarious. Look, a train. So how does the game of Hangman work? Well, like I said, there's a word that I'm thinking in my mind that's clearly 5 letters long. I have a certain number of guesses, and each time someone guesses wrong, a body part gets added to kind of the hanging man here. Every time someone guesses a letter, I'm going to put the letter in this box, whether it's actually correct or not, so we can track which letters have already been guessed. So let's say the first person guesses the letter A. I would put it in the box, and then if it's in my word, I would fill it in. It actually is in my word. Then let's say they guess T. I'm going to put a T here, and that's actually an incorrect guess, so I'm going to put a body part on here, and they really lose one guess. Let's put an H, and that's also incorrect, so I'm going to lose one. It's a little weird to play Hangman against myself. Let's do E, and there is actually an E here. Let's do R, and there is no R. If we do P, we can put these in here, and you've probably already guessed what it is. L is the last one, and I did correctly guess my own word. Yay. So what kind of things do we have to track as we play this game of Hangman? Well, clearly I have to know what the actual answer is to be able to fill this in. We're tracking the letters that have already been guessed, and we're also tracking kind of the number of guesses we have left in this way of we're drawing body parts, and at some point we'll run out of body parts. So when we make this Hangman game that we're about to make, we're going to be making both a console program and a class. The console program is going to be kind of print lines and things like that, actually letting someone play the game of Hangman. The class is going to handle the question of what does a Hangman game need to track? Stuff like the letters that have been guessed, how many guesses you have, and kind of the puzzle itself down here. So let's go and let's take a look at what we're given. Look, here's the Hangman console program. This is the idea of how do I actually play Hangman. And here's the Hangman game, which is the idea of what do I actually need to track, what variables do I need to update as I keep going. This is similar to when we did the Die Hard program and we had the water puzzle class and the Die Hard program. One of those was figuring out how do I solve the water puzzle by pouring water from jugs back and forth. And the class was kind of how do I figure out the math of the pouring and what happens when I fill the jugs and things like that. Similar thing here. Let's open up the console program. And this is where we are going to write again, like I'm playing the game of Hangman. So let's start with this. Let's say print line. Let's play Hangman. Now, if we think about it, when does the game of Hangman end? Well, either I win or I lose. There's kind of 2 different conditions. So to make it a little easier on ourselves, let's do this. I'm going to make a new variable that's going to be a Boolean. And remember, a Boolean is that idea of true or false. I'm going to call this still playing. And let's set it to true. When we first start out, yes, we are still playing. Let's do one more thing before we actually start playing the game, which is I'm going to create an instance of something called a Hangman game. So Hangman game equals new Hangman game. Open, close. Now, again, I don't know what the methods of Hangman game are. We are going to write this as if we can just assume that some of these methods are going to exist, and then we're going to write those methods ourselves. So again, when am I playing the game of Hangman? Well, clearly, while still playing equals true. Now, if you think about it, this is a console program, right? It's not going to be graphics. We won't see the little man being drawn. But what does the person need to know before they start making guesses? Well, if we look at our example over here, they need to know what letters have already been guessed. They need to know kind of what part of the puzzle is still needing to be filled in. And they need to know how many guesses they have left. So let's do this. Let's start by saying print line game dot. If I say game dot, what could possibly follow that dot is a method of the Hangman game class. And again, we're just kind of making them up right now. We're going to code these all later. So let's do game dot get puzzle. That's going to be this part on the bottom with kind of the dashes and maybe some of the letters filled in. Then let's do print line letters guessed plus game dot get letters guessed. And one more, let's do print line guesses left game dot get guesses left. Okay, now all of the relevant information has been printed out. So how do I actually play the game of Hangman? Well, my user, whoever's playing, has to make a guess. So let's do this. String guess equals read line, enter a guess. Now, once they make that guess, what do I need to do? Well, if it's a good guess or a bad guess, I need to be able to figure that out. And based on that information, I may be updating maybe how many guesses I have left, maybe the puzzle, stuff like that. All that updating is going to happen inside the class. Remember, it's the job of the Hangman game class to figure out what happens to kind of all of that information in the game itself. But I still probably want to give the user some feedback if it was a good guess or not. So let's do this. If game.makeGuess equals true, we're going to have this method called makeGuess that's actually going to return a Boolean. True represents it was a good guess, and false represents it was a bad guess. So let's just print line good guess. You can be a little more creative here if you want to. That's okay. I'm just going to leave mine as this. Else, let's print line bad guess. Now that they've made this guess, couldn't the game potentially be over? Remember, the two ways that the game can be over are someone can correctly guess the actual answer, or someone can lose all of their guesses. So let's do the bad thing first. If game.get guesses left equals 0, then I've lost. So let's do two things. Let's say still playing equals false. And then let's also do print line you lost. So sad. And if we're nice people, probably we should tell them what the correct answer was. So let's print line the answer was game.get actual answer. And I think there's one more if statement here. If, how do I tell if I've won? Well, this puzzle that we print out at the beginning is going to be kind of the word with some dashes in between where there's letters missing. Once I've filled in the entire puzzle, won't the puzzle actually be exactly the same as the actual answer? So let's do this. If game.get actual answer, that's a string, so I'm going to do dot equals game dot get puzzle. Kind of a crazy line that I wrote here, but what does this mean? If the actual answer in my Hangman game is the same as my puzzle, aka I've guessed the answer, let's say still playing equals false. Let's print line. You win. And I think that's all we need to do. So let's compile this. Right now, actually, it won't compile because, oh no, we haven't written any of these methods. So let's get to it. Let's open up the Hangman game class. Let's pop this out into its own window so I can have them side by side. And even though this is the game of Hangman, of course we're going to follow the exact same steps that we normally do, which means we're going to start by figuring out the method signatures. Then we're going to do our private instance variables. And finally, we're going to fill them in with some code. So method signatures. We weren't actually given the constructor here. So let's write the constructor. Public Hangman game. No parameters. So I think that's the constructor. That's good. Let's look for the methods of this class. Remember, anywhere I see game dot something, that something has to be a method of Hangman game. So I'm going to need to write a method called get puzzle. What type should that return is probably a string. So public string get puzzle. No parameters because, again, these parentheses are empty. And then here we've got another one. Public string get letters guessed. We've got one here. Get guesses left probably returns an int. So public int get guesses left. We've got this funky one here in the if statement. And look, I'm checking that the result of this is either true or false, which means make guess is going to return a Boolean like we talked about. So let's do public Boolean make guess. Remember, that Boolean actually represents yes, it was a good guess or no, it wasn't. And this also takes in a parameter, which is a string guess. And then it looks like we have one more down here, which is game.getActualAnswer. So public string get actual answer. And it looks like these are our methods of the Hangman game class. All right, we've done step 0. That was our method signatures. Let's move on to step 1. Step 1 is to determine my private instance variables. And again, what does that mean for the Hangman game class? Well, it's everything that a Hangman game needs to track. And just looking at this really beautiful picture that we drew over here of our Hangman game, what kind of things does the Hangman game need to know? Or what is it keeping track of? Well, clearly I'm keeping track of the letters that have been guessed. I think I'm also pretty clearly somehow keeping track of how many guesses I still have. And one thing that's actually kind of not really on the screen but was in my head the whole time is that I actually need to know what the answer to the puzzle is. So I think those 3 things are what we need to track. Now, we don't actually need to track the kind of in-progress puzzle that might have some dashes in it down here, because if you think about it, if I know the actual answer and I know what letters I've guessed, can't I kind of figure this out using a little bit of CS magic? I actually can. So let's do this. Let's go up to the top and let's say private string answer. Private string letters guessed and private int guesses left. This is where I'm going to get rid of this side of the console program, and we don't really need that anymore. Let's just have the class open. All right, what's the job of the constructor? It's to initialize the private instance variables, which means I need to have answer equals letters guessed equals and guesses left equals. Now, you might be wondering, where does the answer come from? There's actually one more class in here that I have not talked about yet, which is this thing called a random word generator. Now, don't really worry about what I'm going to do here because we'll talk about what I'm doing specifically later on this year, but we're going to type this, random word generator dot get random word. This allows our game of Hangman to be super fun because I don't actually have to worry about choosing a word. We can play with a random word, so you can actually play yourself without doing the crazy thing I did here, which is me knowing my own word playing against myself, which was not the most joyous experience ever. All right, when I first start up a game of Hangman, have I guessed any letters? No. Now, some people's default to that is just to put 0, but that's actually not the right thing to do because what type is letters guessed is it's a string. What I actually want is a string that has no characters in it. And how I do that is just quote, quote. Then guesses left. This is a point of great contention. How many guesses do you actually get in the game of Hangman? I think I would argue 6, kind of head, body, leg, arm, arm. There are some people who like to really embellish their little guy, maybe give him a face or something like that, or other stuff. I'm going to leave mine at 6. You are welcome to do whatever you would like. Now, let's do the easy ones. I think a few of these methods are pretty straightforward to get. Get puzzle is actually a little more complicated because like we talked about, we're going to have to do a little bit of CS magic to figure out the puzzle from the answer and the letters we've guessed. Get letters guessed, though, I think is pretty straightforward. Don't I have a private instance variable for that? Remember, this is not void right here, which means I need that word return, and what I'm returning is the letters that I've guessed. Same thing with get guesses left. It's going to be return guesses left. Make guess ends up being a little more involved, so we'll leave that. The last one here, get actual answer, is this not just return answer? All right, let's save get puzzle for last. Let's do make guess here. What happens when I make a guess? Well, I need some way to figure out if it was a good guess or a bad guess. And again, that's what I'm returning a Boolean based on that. I need to update at least one of these variables. I think the letters guessed needs to add in this letter. I should probably also check to see if it's a letter that I've already guessed. So I think there's a few things I have to do. First, how do I check if it's a letter that I've already guessed? Well, I can check that it's in my letters guessed. And if it is, then I've already guessed it. Which one of these methods can we actually use to do that? It's going to be index of. Remember, that's how we find where a string is in another string. So let's do if letters guessed dot index of guess. If guess is in letters guessed, this will be something greater than -1. That's bad, which means what do I want to return here is return false. Now, if we were being really mean, maybe we would also say that you lose a guess by doing that. But we're just going to say if you guess a letter that you've already guessed, we're not going to make you kind of lose a life for that. We're just going to make you have to guess again. Now down here, I know that I've guessed a letter that hasn't been guessed yet. Let's add it into letters guessed. So I'm going to say letters guessed equals letters guessed plus guess. And I just wanted to show you there actually is a shorthand for this in the same way that there is when you do plus with math. You actually can say letters guessed plus equals guess. That's totally allowed. I'm going to leave that commented there. I'll leave the top one as the way that I'm doing it, but you'll see me use this way a lot more. Once I've added it into the letters guessed, I need to check if it's a good guess or not. So how can I check that? Well, it's a good guess when my guess is in the real answer. So isn't it if answer dot index of guess is greater than -1? Again, what does that mean? Is that guess is somewhere in the actual answer. then that's a good guess. I can return true. And I don't need to update my number of guesses that I have left because it was a good guess. Else, if I make it to this else, that means my guess was not a good guess, unfortunately. So there's two things I think I need to do. I need to return false, and I need to make the number of guesses go down by 1. Now, the order of those two statements matters because remember that special thing about return. It ends the method, which means return has to happen last. So let's do guesses left minus minus. Remember, that's that fancy way of saying guesses left goes down by 1. And then return false. And there's one more method left here. So I'm going to scroll up. Let's do get puzzle. Now, just for a little example, let's say my word is apple. And let's say the letters that I've guessed are R, L, E, and N. What would my puzzle look like? Well, I haven't guessed A, so that would just be a dash. I haven't guessed P, so these two would be dashes, but I would put the L and the E because they are in my letters guessed. So what I need to do is, don't I need to go through every letter that's in the actual answer, check if it's a letter that I've already guessed. If it is, we're going to add it onto the puzzle that we're going to build up. And if it's not, we're going to add on a hyphen instead. So you can see that as I went through and did this, I was kind of adding up the puzzle letter by letter. So let's do that. Let's actually start with an empty string, and we're going to add on characters and letters to the puzzle once I've checked to see if I've already guessed them or not. So let's do this. String result equals quote, quote. Like I said, we're starting with the empty string. We're going to build up into it. Then I need to individually look at every single letter of my word here. So let's do a for loop. For int I equals 0, I is less than answer dot length, I plus plus. We've done this before. Let's grab the individual letter that I'm looking at. So string letter equals answer dot substring from I to I plus 1. And now there's two cases here. I'm looping through the answer. So either this letter in the answer is one that I have already guessed, in which case I want to add the letter to result. Otherwise, it's not one that I've already guessed, in which case I want to add a hyphen to the result. So let's do this. If letters guessed dot index of letter, if that's greater than -1, doesn't that mean I've already guessed that letter? Which means I actually want to add it into my result. So let's do result plus equals letter. If I make it to this else, that means this is not a letter I've already guessed. So I don't want to reveal it yet. Let's do result plus equals, and we're just going to do a hyphen. At the very end of this for loop, let's return result. And I think we've coded everything inside our Hangman game class. Let's see if it works. Let's compile, and let's go here. You might have to recompile your Hangman console program. Oh, there's one more thing I forgot. Let's go back into Hangman game for just a second. If you can scroll down to your make guess method, one of the things that I completely forgot about is that the random word generator always generates words that are all uppercase. So let's force our guess to be uppercase at the very beginning of make guess. So I'm going to say guess equals, we've seen 2 lowercase, there's also a 2 uppercase. So guess dot 2 uppercase. And you do have to write it as guess equals guess dot 2 uppercase because this actually returns a string. It doesn't change my guess. So now let's compile this and let's run it. And let's see what this looks like. Okay, 4-letter word. I feel like this is going to be kind of tricky to get. A, bad guess. Okay. E, bad guess. Uh-oh. U, I, O. Uh-oh. I have 2 guesses left. It's a double O in the middle. It could be foot could be fool, could be tool. Let's try L. Oh, uh-oh. T, last guess. Oh, it was rook. Oh my gosh, it got me. And now you can actually play this over and over again. You now have your own kind of random word generating game of Hangman. You can clearly see how this game had a lot to do with strings.